Today we're going to investigate the properties of light. A property is an attribute, quality, or description of something, usually in a way that can be quantified or compared. Light has many properties. Fundamentally, its properties are intensity, which is brightness, direction, frequency, which is color, and polarization. But we can investigate the properties of light more generally by seeing how it behaves in different circumstances. For this physics lab, you will need a flat mirror and something to help stand it upright, like clips or clothespins or books, a piece of paper and pencil, a ruler, a protractor, a straight pin or thumbtack, and a laser pointer. Step 1. Take your piece of paper, fold it in half, and then use the ruler to draw a line along the fold. Step 2. Stand your mirror on top of the line. Make sure it's straight upright. You can use document clips or clothespins or something else that's on hand to hold the mirror steady. Don't let the mirror move at all during the lab. Step 3. Draw a large dot or cross on the paper, in front of the mirror but towards one side of the paper, meaning not right in the middle. Then stick a pin or thumbtack in the dot or cross. The longer the pin, the easier it will be to complete the lab. A thumbtack is a bit short, though it's definitely usable. Step 4. Lower yourself until you're looking right along the surface of the paper. Position your eye in front of the mirror, but at the opposite side to the pin. Step 5. Use the rule to draw a line from your eye along the paper to where the pin appears in the mirror. Do this carefully, as you would if you were playing pool lining up a shot. Step 6. Repeat step 5, but from a slightly different position on the paper. Move your eye somewhere else. After this, you should have 2 lines on your paper from the 2 different positions where your eye was to where your eye saw the pin in the mirror. Step 7. Remove the mirror and extend your 2 lines until they cross using the ruler. Keep the line solid on the side of the mirror where the pin was, but dash the lines on the opposite side of the mirror. Step 8. Where the lines meet the mirror, connect them to the dot or cross you drew. Usually the 2 lines should meet the mirror and then bounce off until they reach the dot or cross. Step 9. Where the line bounces off the mirror, draw a line at 90 degrees, right angles to the mirror surface. Use a protractor if you're not sure. Step 10. Measure the angle between the line from your eye and the 90-degree dashed line and note it down. Also measure the angle between the reflected bounce line and the 90-degree dashed line and note it down. Step 9. If you have a laser pointer, put the mirror back in position, shine the laser along each of the lines you drew from your eye, right along the surface of the paper. You should find they bounce off the mirror and follow the line you drew to meet the pin. If you haven't already, now it's time to pause the video and get started. Good luck. What do these observations tell us? Well, they show us one of the properties of light. That light travels in straight lines. It travels in a particular direction. The light in the room hit the pin and bounced off it, illuminating it. Then one of the light beams hit the mirror and bounced, reaching your eye. The solid lines you drew represent how the light bounces off the mirror to reach your eye. And that's what makes the pin look like it's inside the mirror. That's how mirrors work. The object appears to be behind the mirror, opposite where the pin actually is. The laser pointer shows you that this is true. The laser pointer is like a beam of light, so you can see exactly how it moves when it hits the mirror. In fact, you can go further than that. By measuring the 2 angles, you should have discovered that they are the same size. This means that light must bounce symmetrically off mirrors. Or, if we're going to use the correct terms, the incident angle is equal to the reflected angle. This is called the law of reflection. The fact that the laser pointer is red also shows you another property of light, frequency or color. Red light has a low frequency, and blue light has a high frequency. Other colors are in between. Regular white light contains a mix of every color, which is why it can be broken apart to form a rainbow. A property is an attribute, quality, or description of something, usually such that it can be quantified or compared. The properties of light are intensity or brightness, direction, frequency or color, and polarization. We investigated the direction and the frequency or color of light in today's lab. We showed that light travels in straight lines, that it bounces symmetrically from the surface of mirrors, and that light can be colored like a laser. White light contains a full rainbow inside it.